Hello children, let's continue with our chapter Matter in Our Surroundings, Part 3. Children, you've already come across this word earlier also in your junior classes, and that is temperature. Now we all know that temperature is defined as the degree of measure of hotness or coldness of a body. The common unit for measuring temperature is degree Celsius, that we've already learned earlier as well. Along with that, we have also learned one more measuring temperature unit, and that is Fahrenheit. The laboratory temperatures which we use for performing science experiments, they all are calibrated in degree Celsius scale. In fact, the clinical thermometer which we use for measuring human body temperature, that is also recorded on Celsius scale of temperature only. The melting point of ice on Celsius scale of temperature is 0 degrees Celsius. However, the boiling point of water on Celsius scale is 100 degrees Celsius. But now in class 9th, we learn another scale for measuring temperature, and that is Kelvin. This Kelvin was invented by a scientist named Lord William Thomson Kelvin. He denoted it by a symbol capital K. The advantage of using this Kelvin scale is that all the temperatures on this scale are positive. The melting point of ice on the Kelvin scale is 273 Kelvin, and boiling point of water on the Kelvin scale is 373 Kelvin. Children, please note that we never use a degree sign to write the temperature of Kelvin scale. The symbol for Kelvin scale is only capital K. Now there is a relationship which will help us to convert the Kelvin scale to degree Celsius or degree Celsius to Kelvin scale. So there is a relationship given on the screen, as you all can see. Temperature on Kelvin scale is equal to the temperature on the degree Celsius plus 273. Now, you need to learn this relationship and remember that if we are converting a temperature on Celsius scale to the Kelvin scale, we have to add 273 to the Celsius temperature. But to convert a temperature on Kelvin scale to the degree scale, we have to subtract 273 from the Kelvin temperature. So I repeat, to convert a temperature on Celsius scale to the Kelvin scale, you have to add 273 to the Celsius temperature. But if you are converting a temperature on Kelvin scale to the Celsius scale, then you have to subtract 273 from the Kelvin temperature. Now I hope you can see a picture on your screen, and here you can see 3 measuring units, 3 thermometers showing the various measuring units: Kelvin, Celsius and Fahrenheit. So in this you can see the various temperatures which shows the melting point of ice and boiling point of water on 3 different scales. So at 0 degrees Celsius we can see that the ice freezes. The water freezes to form the ice. So that is your melting point of ice. And at 273 Kelvin, again, that is your freezing point of ice. The water freezes to form the ice. But boiling point of water in the degree Celsius scale is 100 degrees Celsius, and in the Kelvin scale it is 373 degrees Celsius. Now children, these are the 2 examples, 2 numericals given on the screen, which will help you to convert a degree Celsius to the Kelvin scale. And in another numerical, we will learn how to convert a Kelvin scale to the degree Celsius scale. Okay children, these are the 2 sample numericals given for you on the screen. So always remember, whenever we are doing such conversions, do not forget to write down the relationship. The temperature on the Kelvin scale is equal to the temperature on Celsius scale plus 273. So in the first numerical, you all can see that we are converting the degree Celsius to the Kelvin scale. So we just simply need to add 273 to the degree Celsius temperature in order to get the Kelvin scale temperature. So when the temperature given to us is 25 degrees Celsius and we have to convert to Kelvin scale, so the relationship says temperature on Kelvin scale is equal to temperature on Celsius scale plus 273. So 25 plus 273 will give us 298 Kelvin. So temperature of 25 degrees Celsius on Celsius scale is equal to 298 Kelvin on the Kelvin scale. However, if you look at the second numerical, in this case we are converting 300 Kelvin to Celsius scale. So again we will write down the relationship, and here to calculate the temperature on the Celsius scale, we will subtract 273 from the temperature given to us in Kelvin scale. So the temperature of 300 Kelvin is equal to 27 degrees Celsius on the Celsius scale. Okay, children? Now children, let us understand the change of the state of matter. In our previous lecture, I have already taught you about the states of matter. But do you know that we can even change the state of matter? Change the state of matter means that we can convert solid to liquid, liquid to gas, or gas to liquid, liquid to solid, or solid to gas, gas to solid. Okay, now the picture that you can see on the screen says that when we are going from solid to liquid, there is a word written over there, plus heat. And when we are going from liquid to solid, there is a word written over there, minus heat. So plus heat means that we are providing more heat energy to it. That means we are increasing the temperature. But once when you find minus heat written over there, that means we are decreasing the temperature. Cooling is taking place. Okay, children? So on heating, what happens? Ice melts into water, and again when we heat the liquid, then we are converting the liquid into the gaseous state. That means the water vapor. So we can change the physical state of matter in two ways. First, by changing the temperature, and another is by changing the pressure. Now, what are the exact factors which are responsible in changing the temperature as well as the pressure? Okay, we all know that matter is made up of particles, and size of the particles is very, very small. This we have already done in our first lecture. Okay, now when we are talking about the changing temperature and changing pressure, then we need to understand three important things that we will be doing in detail in our upcoming slides. Now we need to understand the spaces between the particles of matter, the force of attraction between the particles of matter, and the kinetic energy of the particles of matter. Okay, children? So with the help of these three factors, we will be able to understand that how does a change in the state takes place. I repeat, children, spaces between the particles, the force of attraction between the particles, and kinetic energy of the particles. These are the three important factors which will help us in determining that how can we change the state of matter from solid to liquid to gas. Children, let us understand the effect of change of temperature. The first process is melting. So if we try to heat ice, it changes into water. That means solid is changing into liquid substance. The process in which a solid substance changes into liquid on heating is called melting. That means melting is a process in which we are supposed to provide heat to the solid substance. This melting process is also known as fusion. So when ice changes into water on heating, it is called melting of ice. It is also known as fusion of ice. The melting of a solid substance always takes place at a particular temperature. The temperature at which a solid substance melts and changes into liquid at atmospheric pressure, that is called melting point of a substance. For example, ice melts at 0 degrees Celsius to form liquid water. So what is the melting point of ice? Melting point of ice is 0 degrees Celsius. That means at 0 degrees Celsius only ice is changing its state from solid to liquid. Now when we talk about different substances, then we will come across, as you all can see on the screen, that different substances have different melting points. For example, melting point of iron is 1535 degrees Celsius. Melting point of paraffin is 52 degrees Celsius. And melting point of ice is 0 degrees Celsius. When we talk about the melting point of a solid, then we will say that melting point of a solid substance is the measure of the force of attraction between the particles. We all know that matter is made up of particles, that we've already done in our previous slides. So the particles, whether it is atoms, whether it is molecules, so the particles of the solid state takes place during melting. They are measuring the force of attraction between them. So remember, the melting point of a solid is a measure of the force of attraction between the particles of a solid substance. Higher the melting point of a solid substance, more will be the force of attraction between its particles. For example, as you all can see, that melting point of iron is 1535 degrees Celsius. That means the force of attraction between the particles of the iron is very, very strong. When we talk about the different melting points, more the melting point, more the force of attraction between the particles. Less the melting point, less the force of attraction between the particles. So if we can compare the melting point of iron and that of the ice, then we will say it has a very strong force of attraction in the case of iron. The particles of the iron are having very strong force of attraction. However, the particles of ice are having weak force of attraction. Now, what exactly is the chemistry behind the melting process? When we say that the solid is heated sufficiently, then it changes its physical state and it becomes a liquid. This is basically happening because a solid substance, when it is provided heat to it, then each particles which are placed at its own specific place, because we all know that in the solid state there is a regular arrangement of the particles. All particles have fixed positions. So our aim is to break those fixed positions and we want them to move. But how will we help them to move? When we are providing heat energy to it. So when we are providing heat energy to it, our aim is to break the force of attraction between those particles. Another aim is to increase the spaces between the particles. So if we are providing more and more heat to it, then what will happen? We are trying to break their force of attraction by increasing the spaces between them. So at melting point, what happens? The particles of a solid substance. The particles of a solid substance, when they have reached their melting point, then they are able to gain sufficient kinetic energy. When they gain sufficient kinetic energy, then they overcome the force of attraction which is holding them in their fixed positions. Now children, our aim is to break apart that force of attraction which is there in the solid state of matter. When we are increasing the heat energy, then we are increasing the spaces between the particles, and along with that we are even increasing the force of attraction. We are decreasing the force of attraction between the solid state. The force of attraction is decreased and the spaces between the particle is increased, and henceforth we are able to convert the solid state of a substance into the liquid state. Water normally exists in the liquid state. When we are giving heat, energy to the water, then ultimately water starts boiling and it is converted into the gaseous state. That means water is converted into the vapor. The liquid water changes into the gaseous state, then we can say a change of state has taken place. So, what is boiling? The process in which a liquid substance changes into a gas rapidly on heating. That means, children, we are providing heat to the liquid substance. When we are providing heat to the liquid substance, then we are changing one state into the another state. That means the liquid state is converted into the gaseous state. The boiling of a liquid takes place at a fixed temperature. So, the temperature at which vapor pressure is equal to the atmospheric pressure, that is called the boiling point of the liquid. The boiling point of water is 100 degrees Celsius. That means at 100 degrees Celsius, the water changes its state from liquid to the gaseous state. That means the vapor state. So there is a fixed temperature. Now, if we talk about the different substances that you can see on the screen, different substances have different boiling points. As you can see on the screen, boiling point of iodine is 184 degrees Celsius. Boiling point of water is 100 degrees Celsius. But boiling point of mercury is 357 degrees Celsius. Now, why do different substances are having different boiling points? Different substances are having different boiling points because there is a difference in the force of attraction between the particles of these different substances. If the boiling point of a particular substance is higher, that means the particles of that liquid substance are having higher force of attraction between them. This tells us in order to break apart those force of attraction between the particles, we need to provide the higher energy. Let us take the example of mercury. Mercury is having the highest boiling point amongst the three substances that you can see on the screen. That means we have to provide more heat energy to this mercury substance. Now, what exactly happens during boiling? During boiling, when a liquid is heated, the heat energy makes its particles to move faster. When we are providing heat energy to the particles, then our aim is to increase the spaces between the particles of a liquid state. On the other hand, when we are increasing the spaces between the particles of a liquid state so that it can be converted into gaseous state, we are also trying to reduce the force of attraction between the particles, which is actually holding them to form the liquid state. At the boiling point, the particles of a liquid have sufficient kinetic energy so that they can overcome the forces of attraction between the particles of liquid state, which is actually holding them together. And thus, we are trying to separate these individual particles so that they can be converted into the gaseous state. So, children, remember that boiling is a sub-process in which we are trying to break apart the particles by providing heat energy to it. Our aim is to create spaces between the particles of the liquid state and to reduce the force of attraction between the particles of the liquid state, thereby converting them into the gaseous state. Children, now your homework. Please read your NCERT textbook thoroughly and do question number 1, 2, 4 and 6 on page 12 of your NCERT textbook in your chemistry fair notebooks. Children, we will be using ruled notebook for chemistry fair notebook. So please complete your work in your fair notebooks now. Thank you.